Okay, so Johnny says that multiplication always makes numbers bigger. And explain to Johnny why this isn't true, because that is not true. If I'm going to multiply like a whole number by a whole number, yes, my number does get bigger. But these numbers, that can include a whole number and a fraction. And when you multiply a whole number by a fraction, your answer is not going to get bigger. Your number is not going to get bigger. So here is an example of why this is not true. So let's take a whole number of 2. And I want to multiply it by, I'm going to multiply it by 1/2. That's just kind of a simple thing, okay? And so when I have this, 2 times 1/2, well, that's going to give me 2 times 1 is 2. And then my denominator is 2, or remember there's that invisible 1 underneath. 1 times 2 is 2. So this answer equals 1, okay? Well, now if I go ahead and let's do another one, because remember 2 is my whole number that I've started with. Here, let's try this one. Let's do 2 times 1/8. Okay, so if I have 2 times 1/8, I have 2 times 1 is 2. Then 1 times 8 is 8. 2/8 I can simplify down. That answer is going to be 1/4, guys. So if you take a look at this, 2 is going to be less than 1. And then 2 is going to be less than that 1/4. And I created that because I multiplied a whole number by a fraction. It doesn't matter. This is a number. This is a number. That whenever you multiply, just because you're multiplying does not necessarily mean that your answers are going to be bigger at all times, okay? This next one says, a company uses a sketch to plan an advertisement on the side of a building. The lettering on the sketch is 3/4 of an inch tall. So I'm going to write 3/4 of an inch tall, okay? The actual advertisement, in the actual advertisement, so this is just kind of their sketch and like their plan. Their actual advertising is each letter must be 34 times as tall. So of course, when you do this, you can't necessarily put 34 times as tall as that, because we're going to look to see how big the letters are, and I don't think you're probably going to want to have that necessarily on a plan for that. So what I can do is I know 35 times as tall. I know what I want to do is I want to multiply these two numbers. So I'm going to go 34 times 3/4. Okay, and remember when I do this, I'm going to do 34 times 3. Oops, 34 times 3, not 3 times 34. So 34 times 3, and then I'm going to have my denominator is 4, because remember this is your invisible 1. 1 times 4 is 4. So then I'm going to do 34 times 3, that's 12, 102, because 3 times 3 is 9 plus 1 is 10, so 102 fourths. And I don't want to leave that, so I want to convert that. So 102 divided by 4 goes in 5 times. I'm running out of space. 20. I get 2 left, so it's 2/4. So 25 and 2/4, or each of those letters has to be 25.5 inch tall. Okay. And so this is the reason why they kind of had that scale, but then also if you notice, it has to be 34 inches at 34 times as tall as what they had when they replicated it on their sketch, and so that's why my number is going to be smaller, okay? It says Jason is drawing the floor plan of his bedroom, and he says he's drawing everything with dimensions that are 1/12 of the actual size. And that's kind of normal that when you even look at a map, your map's not going to be able to show you how many miles in actual miles it is between one city and another. They have what they call a scale, and it's basically like if you look at your map, every inch might mean like 100 miles, and I'm just kind of making that up. It probably is not true, but you can't necessarily show everything when you're trying to make a plan. I mean, think about your bedroom. If you were to make a floor plan of your bedroom, you're not going to make a floor plan of the actual size of your bedroom. You're going to scale it down a little bit, and that's what this is it's scaling it down. So it says that his bed, so here's his bed. I'm going to put bed. His bed measures 6 feet by 3 feet, okay? The room, so his room room is 14 feet, and I'm going to go in and put my labels here, by 16 feet, okay? And so what I want to do right now is when I'm looking at this, and I could have put his bed in here, but I just kind of wanted to do it two separate ones, is that what I could have done was I could have, oh, sorry guys, I was talking about how I could have gone through and done this. So what I need to do right now though is I need to figure out what is the, if I'm going to do a 1/12 of each of these, what would that necessarily be? So what I need to do is I need to basically kind of figure out, if I'm going to do his bed here, I want to figure out what is this scaled down to a 1/12 and what is this scaled down to a 1/12. So what I'm going to do is I'm going to basically take each of these numbers and I'm going to multiply it by 12, okay? Now, what you might be thinking is, well, why can't we figure out the area and then multiply it by a 1/12? And it's because we don't want to know what the area is. We want to know what would this measurement be when we're scaling it down. What would he have? So I'm going to take the 6 feet, multiply it by a 1/12, okay? So 6 times 1 is 6, and then 1 times 12 is 12. I can divide this by 6. It's going to be 1/2. So this scaled right here, this is going to be 1/2 of a foot when he scales it down to draw it on his papers, okay? So then I'm going to go ahead and take this 3 feet and I'm going to multiply it by 1/12, and I'm going to get 3, and then 1 times 12 is 12, and I'm going to divide this by 3 to simplify it down, and I'm going to get 1/4. So this one is going to equal 1/4 of a foot when he scales it down. So remember, like, your bed might be 3 feet wide, might be 6 feet long. When you're drawing a picture of that, you don't want to draw a picture of your bed that is 6 feet long. You wouldn't even have enough room on a piece of paper. So now I want to do the same thing with our bedroom, is that I want to scale this down. So I'm going to take this 14 times 1/12. I'm going to get 14/12 because what I do here is I just multiply straight across an invisible 1. That's going to be 1 2/12. Or, because I can simplify this, I can divide this by 2, divide this by 2. It's going to be 1 1/6 of a foot. So this side, when he draws it out, is 1 1/6 of a foot. Okay. Then over here, I'm going to do that 16. So I'm going to do 16 times 1/12. I'm going to get 16/12, or 1 4/12. When I simplify that down, because I can divide each of these by 4, I'm going to get 1 1/3 of a foot. Okay, and so this is what that new measurement, what his dimensions are going to look like. Because remember, we're scaling it down. So when we scale it down, we're multiplying it by this fraction to scale it down. And it's so that we can be able to draw something and have it not be in real size.